Hi everyone, I hope you are all good. So I welcome you on this IIT Kanpur PYQ series for GATE. And today what we are going to do, we are going to do the thermodynamics question that have been asked in the IIT Kanpur in the years when IIT Kanpur organized the GATE. So what were those years? Those were 2001, 7 and 15. So please join as quickly as possible so that we can start the session. Let me wait for 1 minute so that we can start it, okay? Okay, so before that, let me make a quick announcement. On 25th of Feb, we are coming up with a question series, a question practice series, which is called as Champion series. So it is starting for 25th of August. And we will be covering a lot of new questions, not from GATE, not previous year questions, a lot of good questions, which is for GATE, right? So you will get a collection of more than 500 questions for GATE, and these are really, really nice questions, very well curated from the books and the questions that have been previously asked. And we will cover all types that you have seen in GATE. So we have multiple choice questions, multiple select questions, and numerical answer type questions, okay? So I hope that you are going to join this series. It will really be beneficial at this point of time because it's revision time. I am hoping that you have covered half the subject at this point of time. So it will be really nice that you practice these questions. Okay. So could you please tell other friends who are about to join this so that they can join as quickly as possible and we can start the session. Okay. So I'm waiting for you so that let us take 1 minute so that enough people join and we can start, right? Okay. So I again suggest you to join this series. It is Champion series, very nice questions, all the subject we are going to cover. And I don't know for sure, but I think we are going to start with strength of material, I think. Okay. But anyway, keep subscribe the BEP channel and you will get the updated schedule there. Okay. So keep following that. That is the main source of your information. Okay. So have enough people joined. I think there are 4 people. Okay, let's move on because time is time. Okay, it's already 6:02. Okay, so just a brief introduction. I have around 4+ years of teaching experience. I have done my MTech from IIT Kharagpur. I have also done MSc and some research at Politecnico di Milano, Italy. I have some research experience, industry experience as well, and some publications. Okay, my area of expertise is, as you all know, I am taking thermodynamics with you and heat and mass transfer, RAC, power plant, IC engine. Okay. I also suggest to you, please join my Telegram channel. Okay. We are working on making it more interactive for you. So join my Telegram channel. This is Mechanical by Vipin Yadav. Okay. It will really be beneficial for you. We are planning to make it more interactive. Okay. So other sessions as well. So join this Telegram channel, which is Mechanical by Vipin Yadav. Okay. So can we move on to the questions? Can we move on to the questions? Okay, so let's it's already 6:03. Okay, so let us move. Before we go into questions, let's do a quick analysis. Let's do a quick analysis of what type of questions from thermodynamics IIT Kanpur prefers. Okay, as we all know, even though IIT Kanpur is conducting GATE, but basically all the committee consists of all the IITs, okay? But the selection is made by IIT, okay? It's the conducting committee, right? But still, like it's better to know what is the mindset of IIT Kanpur when they set the paper. So as we all know, we are covering after 2000. So after 2000, IIT Kanpur conducted in 2001, 2007 and 2015. So a quick analysis of thermodynamics questions that I have done, and I have divided all the topics into these parts just for the convenience, okay? We can also divide just first law and second law, that's all, okay, and basics. But I have divided into several parts. So if we see here, there are certain conclusions that we make. The first conclusion is, out of total 21 questions from thermodynamics, okay, so on basics and zeroth law, there are total 4 questions in those 3 years combined. Okay, first law open system, 4 questions. First law and second law 5 questions. All 3 years combined. All 3 years combined. What we are seeing here, that there are total 5 questions from second law, right? Entropy, we have 1 question. Okay, availability and irreversibility. Now the first conclusion that can be drawn, that out of 21 questions that are totally asked in GATE in these 3 years by IIT Kanpur, 2/3, 14 questions are numerical type, okay, which is 2/3, right? Out of 21, this is 2/3, and 7 questions are from theoretical, conceptual, okay. So this is the first conclusion, that 2/3 of the total questions are numerical type and 1/3 is conceptual type. So they tend to incline towards numerical question, okay. The second conclusion is that after pure substances, if we see, there are total 5 questions, but they are all theoretical except this ideal and real gas. That was also theoretical based, but mostly after pure substances, thermodynamic relation, ideal and real gas, most of the questions are conceptual questions. You see, these questions are ideal, pure substances, ideal and real gas, and thermodynamic relation. Most of the questions are theoretical. Okay, so basically that is, you can make a mindset of how to prepare thermodynamics. Okay, so for these chapter you should prepare your concepts very very nicely. So that is what you need to work on. Now other thing that we can conclude here is, a lot of question has come from open system, okay, steady flow and unsteady flow, right? And second law, refrigerator, heat pump, heat engine. Very simple questions have been asked from second law. So around 9 questions out of 21 have come from first law and second law. Okay, so you see they are very important. Also, I would suggest closed system they have not asked. Numerical they have not asked. Okay, no numericals have been asked from the closed system. So you can focus on that as well. So there are 2 topics that I would suggest that you focus on. You have to focus on open system and second law for sure, but you should also focus on closed system and entropy. Okay, numericals, because this year they can go through this from these topics. Okay, also very basic and zeroth law. In fact, I did not find any question from zeroth law. These are all basics. Okay, 3 questions have been asked, numerical, and 1 question conceptual. Okay, so I hope, yes, Sachin, that is right. Good evening, Sachin. PK Nag is a very nice book. Although there are other good books, but particularly for GATE, PK Nag is a very, very nice book. Okay, for practice, especially for GATE. Otherwise, if you want to cover more realistic examples and all, then there are other books. Okay, but PK Nag is a wonderful book if you want to practice questions directly for GATE. Okay, if your exam focus is on GATE, then PK Nag examples are really, really good for GATE. Okay, so I hope, to conclude, out of 21 questions, 2/3 questions are from numerical, 1/3 is conceptual. So they are little bit inclined towards numerical type questions. Second, a lot of questions have been asked from open system and second law. So focus on these areas. Also, they have never asked closed systems, first law closed system, and entropy, only 1 question. Focus on those as well, okay? Because this year there may be a chance that they can ask from this topic, okay? And zeroth law, I have not seen any question, numerical. But basics, they have asked 3 questions, okay? And after pure substances, ideal and real gas, and thermodynamic relation, you should focus on conceptual questions, because they have asked only conceptual questions, not numerical, okay? Because pure substances, you can find certain numericals that find dryness fraction, find this and that, find temperature of superheated gas or whatever. But conceptual questions are more important than theoretical questions in these chapters, okay? So I hope we are all set to start this IIT Kanpur PYQ series. All questions today come from IIT Kanpur previous year, that is 2001, 2007 and 2015. Okay, so I have not written IIT Kanpur. All questions are from IIT Kanpur. Okay, so let's move on, right? So I hope you got some idea from this analysis, right? And you can plan your preparation according to that. Okay, let's move on. Okay, this is a question. This is 2007 question, very easy question, and 2 marks. Okay, so it was a linked question. It was a linked question, 2 questions all together, 4 marks. Okay, so very quickly read this question and tell me what is the right answer. A thermodynamic cycle is there with an ideal gas working. Ideal gas is working fluid. So we have ideal gas and working fluid. Ideal gas is working fluid. The above cycle is represented on TS diagram by. So we have 4 options, and this is our cycle. This is our cycle. Before we start this, let me tell you, this is PV gamma is equals to constant. There is a mistake in the printing. Okay, so very quickly, can you see these diagrams? You don't need to solve anything here. Just see, take a look on this 4 options, and you must be able to solve this. Okay, can you see this and solve this very quickly? Let me also solve it with you, so that we have to cover 21 questions today, and I want to cover it in, till 7:15 or 7:30 maximum. So I will also solve with you. So what can we conclude from this given diagram? So what we can conclude, we have one constant pressure process, constant pressure, which is 1 to 2, right? Then we have a constant volume process, which is what, 2 to 3, and then we have a isentropic process, reversible adiabatic isentropic process, which is 3 to 1. 3 to 1, these processes are there. Okay, so if we see the options that we have given, A, B, C and D. Okay, I hope you are able to see the option D as well. Okay, so if we see these options, there are 2 diagrams that we can simply eliminate. What are those? C and B. Why? Because this is isothermal process. This is what? Isothermal. This is temperature is equals to constant. This is isothermal process. And in our PV diagram, there is no isothermal process. So I can simply eliminate this. This is not correct. Also, what can I eliminate? Look, this is also temperature is equals to constant, isothermal process. So I can simply eliminate this, right? In the question, the diagram, that PV diagram that they have given in question, Ashwin, that is absolutely correct. D is the right answer. Okay, so just analyze this. In C and D, they have given isothermal, but in the question, there is no isothermal process. So B and C are completely out. They are eliminated out of the options. Sachin, right? D is the right answer. Now, if we analyze A and D, then what we can see, it is anti-clockwise. It is anti-clockwise, but this one is clockwise. Okay, so we are only left with one option. Without even seeing that option, we can mark that correct. Okay, so this is clockwise, right? And this is clockwise, first thing. Then 3 to 1. 3 to 1. So 3 to 1 is isentropic process. You see, S3 is equals to S1. Okay, and 1 is constant pressure and 1 is constant volume. So 1 is constant pressure, 1 is constant volume. So this is constant pressure and this is constant volume. This is constant volume. Okay, this is constant volume. So D is the right answer. Let's move ahead. Okay, I need some space to solve this, but now I don't need it. Okay, very quickly, now the same cycle, it is a linked question. Okay, so 2 marks, 2 questions all together. Same cycle is there. They are saying specific heat of the working fluid is constant. Specific heat is constant and value of specific heat ratio gamma is equals to 1.4. So I need to calculate thermal efficiency of this cycle. Thermal efficiency of the cycle. Can you calculate this? Thermal efficiency. So if you see this cycle is a Leonard cycle, right? One constant pressure, one constant volume, one isentropic. Okay, this is isentropic as I told you. This is isentropic. Okay, So one constant pressure, one constant volume, one isentropic. So if you are solving this, very quickly tell me what is the right answer. Very quickly tell me. Reynolds cycle efficiency, how can you calculate? 1 minus gamma Rp 1 by gamma minus 1 upon Rp minus 1, right? This is how you can calculate. You only have to put the values and you can tell me what is the right answer. Okay? So, are you solving this with me? Very quickly tell me. It's Reynolds cycle, we all know. Now we also know how to calculate efficiency for Reynolds cycle, right? Very quickly tell, everything we know. What is the pressure ratio? What is Rp? Rp is equals to 400, which is P2 by P1. Okay. So P2 is 400 and P1 is 100. So Rp is equals to 4. Rp is equals to 4. So now there is nothing left. Rp we know 1. So cycle efficiency 1 minus 1.4. 1 by 1.4 minus 1 upon 4 minus 1. What is the answer? What is the answer? Sachin, Ashwin, what is the right answer? And anyone else who is there? Can you solve this and tell me? You need to solve this, otherwise you won't get practice, okay? It's very important that you put all the values carefully in the calculator and you should solve the right answer. Because sometimes when you put the values in the calculator, you get the wrong answer because you put it wrongly, okay? So, what is the right answer? What is the right answer for this? 0.21. 0.21. So what is the right answer? A is the right answer. 21%. 21%. Okay. Let's move on to the next question. Okay. Temperature of nitrogen in a vessel of volume 2 meter cube. So what do we have? We have a vessel and the volume is 2 meter cube. Temperature is 288 Kelvin. Why is it coming 0.08? It should not come 0. It is 1 minus 1.4. Calculate it properly. I don't think you should get 4. No. This is 1 minus 0.78 something. Okay. Seven, eight, 9. Sachin, you are doing some mistake in calculation. Okay. Let's move ahead. You are doing some mistake in the calculation. Please try it one more time, okay? Let's move ahead because you have to solve 21 questions today. So what they are saying, we have a vessel and nitrogen is there. Nitrogen is there. Volume is 2 meter cube and temperature is equals to 288 Kelvin. Now what we have done, we have installed a U-tube manometer in this. And it shows vessel knows 70 centimeter of mercury level. It shows the difference is 70 centimeter, okay? So the height of mercury in that U-tube manometer is 70 centimeters. And level higher is the open end to atmosphere. So we have atmospheric pressure as well. Universal gas constant R bar is given. R bar is equals to 8.314 or 8314 joule per kilomole Kelvin. Atmospheric pressure is also given. Atmospheric pressure is given as 101325 Pascal. Acceleration due to gravity is given. Density of mercury is given. Mass of nitrogen we need to calculate. Mass of nitrogen we need to calculate. Okay? Yeah, that is Ashwin, that is correct. 0.21. That is the right answer. Okay? So what we are doing here is that we are assuming, let's assume that nitrogen behaves as ideal gas. So we can apply ideal gas equation, okay, because there is no other way you can solve this question, okay. So PV is equals to MRT. M is equals to PV upon RT, okay. So we have to put the values for pressure, volume and R and T, okay. Now pressure is absolute. We all know pressure must be absolute, temperature must be in Kelvin, okay. So mass if I need to calculate, pressure I need to calculate absolute pressure. Absolute is what? Gauge plus atmospheric. So this will give me gauge pressure. This is gauge pressure, which is P gauge is equals to rho GH of mercury. Rho is what? 13600 into 9.81, okay, 9.81 is given into 0.7, okay. So you should calculate it. I don't know how much you will get, okay. Then P atmospheric is equals to 10, you will get this in Pascal, and P atmospheric is 101325 Pascal. So you can calculate absolute pressure is equals to P atmospheric plus P gauge, okay. 4.82, Suhadeep, I think it's slightly wrong. It should be 4.55, okay. And it is numerical type question, numerical answer type. So try to be more accurate in your calculations. Do not round off, okay. Numerical questions, I would suggest please refrain from rounding off, because if you are rounding off each and every individual figure, that at the end you will get a very different answer, okay. So mass is equals to, I can say, let me write it here, 101325 plus into 9.81 into 0.7. Yeah, pressure, this is what pressure, P absolute, into volume. How much is volume? 2 meter cube. R is what? R bar upon molecular weight of nitrogen. So what can I write? 8314 upon molecular weight of nitrogen is 28 into temperature 288. Now you should get, see how much you are getting. Yeah, okay, 9, okay, yeah, maybe, I don't know, it should be 93391.2 Pascal, probably, I guess so. It should come like this. Yeah, I know the approximate figure, okay. So now you tell me how much you are getting. If you solve this, put this and solve this and tell me how much you are getting very quickly. So we will move on to the next question. 4.654. I think so, but I think if you are getting 4.55, it is more correct. It is more close to the right answer. You should get it. 0.16. How is it 0.16? How it is 101325? So let's move on. You should not get, yeah, 4.56 is more correct. Yeah, that I can agree. It's absolutely correct. Okay, so let's move on. Let's move on to the next question. Okay, tell me very quickly. Same concept. Okay, same concept. We have a well insulated. ठीक है कुछ नहीं. Well insulated. So this is insulated, right? We have a well insulated rigid container. So volume is not changing. Volume is 1 meter cube and mass is there 1 kg of ideal gas. And Cp and Cv is given. Cp and Cv is given. Pressure is 10 to the power 5 Pascal. Now we have a stir. And we are rotating it. We are rotating the stir. Okay. It is doing some work on that gas. It is doing some work, so it is giving work to the system. Now we are applying torque of 100 Newton meter. And we are rotating 1000 RPM. Okay. So 1000 rotations we are doing. Okay. And we need to find out the final temperature of the gas. First of all, we do not know what is the initial temperature. Then they are asking, tell us the final temperature. Okay. So are you working with me? What should we do here? What we can do is, first law of thermodynamics for closed system, because they are saying it is a closed system. Rigid means closed. Okay. Rigid, or even it is flexible, but basically no mass is going in or coming out. Okay. So, and it's a well insulated, so dq will be 0. Okay. Now rigid, it may not be rigid, but it can still be a closed system, like a piston cylinder without valve. Okay. Rigid means the boundary cannot change. Okay. Anyway, so it can be dq is equals to du plus dw, right? 348 Kelvin. No. Solve this again one more time. Try solve this again. 348 is not the right answer, and at least not in Kelvin. Okay, no, not in Kelvin. Okay. I mean, you need to calculate that in Kelvin, but that is far away from the right answer. Subhadeep, I would suggest that I think you are making some mistake in calculations. Okay, so please practice more, because calculations are really important. You should feed the right values in the calculator and solve it correctly, even if you know the concept. But sometimes we feed the wrong values. We make point mistake. We sometimes forget to change the units before putting it. Okay, so put it into the calculator and solve it. Okay, so they are saying insulated. Insulated means this goes to 0. And if you are rotating the stir, that means work is done on the system. So this will be dw plus minus du minus dw. Okay. Because you are rotating the stir, so you are giving work to the system. So this is du is equals to dw. Okay. Now du is what? Mass Cv dt, T final minus T initial. And what is work? How will you calculate work if torque is given? So torque into omega. Okay. Now T initial we don't know. 500 must be in degree Celsius, I think. 500 is in degree Celsius. Okay. 500 is in degree Celsius. No, 500 I think is T initial, right? If I remember right. Anyway, 500 Kelvin is T initial. Why T initial? How will you calculate? Ideal gas is there inside the container, right? So P1 V1 is equals to mRT1, right? So T1 I need to calculate. P1 is 10 to the power 5 Pascal and V is 1 meter cube. Mass is also 1 kg. And temperature and R is equals to Cp minus Cv, that is 200. So I think if you solve this, you will get 500 Kelvin, right? Why other people are not solving? I really would suggest please solve it. It's really important. Even if you know the concept, even if in your mind you know that I will apply dq is equals to du plus dw, I'll cancel dq and I can put this and I can calculate tf. Still, it's very important that you put that in calculator and solve. Very important. Okay. 2585, yes, that is correct. 2585 is correct. Now you know everything. Now there is nothing that is left. It is 1 kg. CV is 800 joule per kg Kelvin. Into T final I need to calculate. T initial is 500 Kelvin. Okay. Torque is 100 Newton meter into 1000 revolutions. So that doesn't have any unit. Now Newton meter is in joule, right? This is joule. So I can calculate T final is equals to 100 into 1000 upon 800 plus 500. Okay. So if you solve this, you will get 1285.4. That is correct. So, Subhadeep, it's correct. I will call you Ghosh. That's easy for me. Okay. So 1285.4 Kelvin is the right answer. Okay. Okay. Let's move on. Yeah, I am sorry. 2 pi n. It is equals to 2 pi n. That is correct. I am sorry. It's my mistake. Okay. 2 pi hoga. Yes, that is correct. Okay. Okay. Thank you. Let's move on. A small steam vessel perfectly insulated, no shaft work. Okay. So Q will be 0, W will be 0. Perfectly insulated means Q will be 0 and doing no shaft work, W will be 0. Causes a drop of 0.8 kilojoule per kg in enthalpy of steam from entry to exit. Okay. If the kinetic energy of the steam at the entry is negligible, the velocity of the steam at exit will be. So let's say we have a device like this. Here we have H1. Here we have H2. Now this device is insulated. Okay. And steam is flowing. So M in, M out. 40 meter per second, absolutely correct. Very nice. Where are other people? Sachin, where are you? And I don't know who else is this. No one has came here. I would really suggest please people come out and answer. Seriously, it's really important. Okay. I don't know if you know the importance of this because it will give you a lot of confidence. Okay. If you come out, even if you are solving on paper and you are not writing it here, I would suggest you write. Okay, because it will give you confidence. It's really important. These things are not just for exam, but in general life as well. Okay, so I know steady flow energy equation, right? I know steady flow energy equation, steady flow energy. Do I need to write the whole equation? I'll write it here, then again I won't write in the next question or if other question comes. Okay, so M in HI plus V1 square by 2 plus GZ1 plus Q in. If Q in is happening, then you will write it this side, okay? Is equals to M out, H out plus V out square by 2 plus GZ out plus if your device is giving you work, then only you will write W out this side. Otherwise, if it is in, then you will bring on the other inside. If it is losing heat, then you will take on the outside. Okay. Now they are saying that this is 0, this is 0. Okay. They are not talking about potential difference, so we are not going to talk about it. They are saying initial velocity is negligible, right? They are saying at the entry it is negligible. So this will go out. This will go out. So what can I write? What can I write? Mass in H in, okay, is equals to mass out H out plus M out V naught square by 2. Velocity at outlet we need to calculate. Velocity at outlet we need to calculate. Right? Sachin, that is right. B is the correct answer. Now, mass in, it is a steady flow, so mass in is equals to mass out. I can cancel mass as well. I can take mass in is equals to mass out. I can cancel because mass is not required here. Now they are saying enthalpy drop is happening. That means that when the fluid is flowing, when the steam is flowing from H1 to H2, enthalpy has reduced to what value? 0.8. 0.8 drop has happened. So H1 can I write is equals to H2 plus 0.8, because here what will be the enthalpy? This minus what has dropped. Okay. So H1 minus H2 is equals to 0.8. If I cancel this and this, H in minus H out is equals to this, and now you can calculate this. Okay. And very, 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 very important. If you are putting enthalpy in kilojoule per kg or in kilojoule, whatever, per kg is a different story. But if you are putting H in kilojoule, enthalpy in kilojoule per kg or kilojoule, if it is capital, then it is kilojoule, okay? If you are putting in kilojoule, then you have to always put here 2000, okay? Here you have to put 2000 and here you have to put 1000. 2000, 1000. If you are putting in joule, then you will use the normal equation, okay? So now you can solve this. 0.8 into 2000, you will get 40 meter per second. Very nice, Sachin. Okay, let's move on to the next question very quickly. It's simple question like last one, steady flow energy question. I think you have to apply here. Power output you need to calculate. We have a turbine. Steam is entering at 300 kilopascal. We don't need this. Enthalpy is 3486 kilojoule per kg. And when it is coming out, enthalpy out is equals to 317875.8 kilojoule per kg. So entry 3486, out 3157. Enthalpy has dropped, but it is a turbine, it will give you some work as well. So you will get work output, okay? And then they are saying heat losses in the turbine are 50 kilowatt. Heat loss means heat is going out from the turbine to the surrounding. So there is heat loss as well. Q out is happening, 50 kilowatt, okay? So Ashwin, that is correct. 40 is what? Power. Please write question as well, okay? Question number 6 or 6 and answer, okay? So that I will know what question you are answering, okay? So if you are solving question number 6, then write 6 and then whatever answer you are getting, so that it will be easier. Anyway, so the answer is 27.55, absolutely correct, okay? Now there is nothing left. There is nothing. Mass is also given. So M in H in plus Q in is equals to M out H out plus W out. Okay. We know mass in is equals to mass out, steady flow turbine, right? So I can write M H in minus H out minus Q in, because it is not Q in, it is Q out. So minus Q in is equals to work output is same because it is giving you work. So Sachin, Maheshwari 27.5, absolutely correct. Sachin, that is absolutely correct. Very nice, very nice. Okay, you must solve the question. Okay, you must solve the question. Also, I would suggest you one thing. If it is a numerical answer type, try to answer up to 2 digit. Right answer up to 2 digit, okay, after decimal. Okay, unless it is written in the question that 1 digit or whatever, Usually they write. But even if it is not written, you try to write the answer 2 digit after the decimal. Okay, so it is 27.55 or 56, whatever it is. So you write it like this. Okay. Okay, let's move on. Which of the following relationship is valid only for reversible process undergone by a closed system? We have a closed system and a reversible process. Very quickly tell me the answer. Question number 7. Which one is the right answer? Question number 7. Which one is the right answer? Question number 7. Which one is the right answer? C, question number 7, C. Why C? C is not correct. You see, first of all, it is true that you cannot apply this for reversible. It is only valid because dq ds is equals to dq by t. Then dq is equals to t ds. So you have put this here. But it is only valid for reversible. So it is true. It is valid for reversible. But you see here dw, you can write pdv. You can write in terms of closed system work, pdv. You can also write open system work, which is what? Minus p1 v1 plus p2 v2 plus the system work, control volume work, right? So you can change your dw anyway. You can apply for closed system. You can apply for open system. So this C answer. C is valid for reversible, but for both open and closed. Okay? You can apply for both. Similarly, A you can apply for reversible or irreversible, open or closed. Option number B, you see, if we talk about B option, this option, temperature is a property, entropy is a property, internal energy is a property, pressure is a property, volume is a property, and property is a point function. So it does not depend on path. So it does not matter if it is reversible or irreversible path, right? So it is valid, this is valid for reversible or irreversible, but only for closed system. Why closed system? Because PDV is closed system work. So only option D is correct because this is valid for reversible. So PDV is what it is? It is reversible closed system work. PDV is reversible closed system work. So if I have put PDV in this equation, that means it is only, this equation is only valid for reversible closed system work. Okay? No, Maheshwaran, B is not correct. I just told you B, why B is not correct, right? Is it clear? Because all are properties, so you can apply, properties are point function. It does not matter that you are going from point A to point B, what path you are taking. It can be reversible, it can be irreversible. It does not matter. Okay? Yeah, let's move on. Very quickly tell me, steady flow energy equation we have to apply. I am not going to solve this. In 1 minute, I'll tell you the answer and I'll move on. Steady flow energy equation you have to apply. Question number 8. I need to calculate what? Heat losses is there. Work output of the turbine I need to calculate. Work output I need to calculate. I will directly tell you the answer and I'll move on. Actually, there is something I know that you are going to do wrong here, but okay, let's see. Tell me the answer. Work output. No, I think this is easy. You can solve this correctly. What is work output? 1 minute, now half a minute is left. Very quickly tell me. 2717, absolutely correct. Very nice, Sachin. Very, very, very nice. 2717. Okay. Everyone is clear with this? So Ghosh, yes, absolutely correct, right? So we can move to the next question. 21 question we need to solve today, okay? It's already, we are above half time, okay? So ninth question, work done in an adiabatic system. We have an adiabatic system due to its velocity. So whenever work is done on a system, we have a system, we are doing work on the system. Because of this work, the velocity is increasing from 10 meter per second to 20 meter per second. Elevation also increasing to 20 meter and temperature is changing to 1 Kelvin. Okay, mass is given 10 kg of the system, CV is given, gravitational acceleration is given, G is given, okay. There is no other change, in the system, okay. So I need to calculate the work done on the system, okay. So I am expecting you are solving it with me. Let me solve this because you can make mistake in this, okay. So steady flow energy equation, let me write steady flow energy equation. If you are solving this and you have solved this, write the answer in the comment box so that we can analyze what mistake you are doing. Steady flow energy equation I can apply. What is this? HI. Can I write this in the form, you know, like I can bring this, okay, leave it. HI plus VI square by 2 plus GZI plus Q in is equals to M out, H out plus V out square by 2 plus GZ out plus work output. Now this device, they have told us 4.5 is correct. Sachin, very right, very nice. Okay, very nice. If other people are solving this and if you tell me the right answer, then I'll move on. I won't solve this. Okay. Now they are saying work is done on the system. So can I bring it the other side? Let me bring this because work is done on the system. So I'll take on the inside of the equation. So work in, I'll take this side. Rest, I'll take everything out other side, okay? So M H naught minus H in plus V naught square minus VI square by 2. Let me write it 2000 here, okay? Plus G Z out minus Z in. I know I am hiding this, your view, but I hope I am saying it as well so that you know what I am doing, okay? Now what is happening? Temperature change is happening, okay? Temperature change is happening. So, and temperature change happens for internal energy and PV as well, okay? So, can I write M is equals to U naught minus UI, okay? Or I can write U naught plus P naught V naught minus UI minus, okay, let me put the bracket, P in V in. Rest of the equation is same. Okay. Now velocity change is coming, temperature change is coming and elevation change is coming. Rest everything, there is no change. So if there is no change, so I can remove this. And M is equals to, let me write on this side, M is equals to U naught minus UI. That means M CV delta T. Delta T is 1 Kelvin, okay? Plus V naught 20 square minus 10 square by 2000. So you have to put this in kilojoule, right? Because I am putting 2000 here. Plus G into 20. This is your work. Yes, Sachin, I'll share. Don't worry, I'll share. I'll share with the solution, okay? I don't think I can share with the solution, but let's see. I'll share the question for sure. Answer I can share or not. Let me see. Let me see. Okay. So have a working substance is not given in the question. No, work is done in which velocity, elevation, mass of the system and gravitational. So what we are using, what? We are using steady flow, no? What is the confusion? Mass is given. Why do you need working substance? Specific heat is there, no? This is given. CV. Is it okay? Is it okay? Then I can move on. Let's move on. Okay. Very simple question. Very simple question. GATE 2001, 2 marks. I don't know why they have asked for 2 marks. Very simple question. Solve this very quickly and tell me what is the right answer. We have a heat engine. Heat engine we have. Solve this very quickly. I am not solving this for you. I'm just killing time, just drawing the diagram, okay? You don't need to draw a diagram. You should be on that level that you should not be able to draw the diagram, that you don't need in the exam. Before exam, always draw the diagram. During exam, you should be at certain level that you should not be, you don't need to draw the diagram of heat engine or refrigerator or heat pump, okay? Everything should be in your mind. Now, what is happening? I am giving certain Q1, and it is giving me work is equals to 50 kilojoule, and efficiency here is 75%. Heat rejected Q2 I need to find out. They are asking heat rejected. 16.67, let me check. Question number 10. Absolutely correct. Yes. Yes, Sachin, A is the right answer. Very nice. Yeah, this is the right speed, okay? If you are solving in this much amount of time, I think you are at a good level, okay? You are approaching to the GATE level. You don't need to draw the diagram. You don't need to draw, just write the formula, okay? And just solve it, okay? So I am moving on. 16.67, I don't think I need to solve this. These are very basic questions. So if you are struggling in this, if you want me to solve this, you can write in the comment, I'll solve this, okay? Otherwise, I don't think that this is August, right? So I don't think that your practice should be, if you are attempting this GATE, then your practice should be of this level that you should be able to solve this very easily, because December you have to finish the syllabus, okay? Otherwise, you are running late on time. Okay, Maishran, yes, A is correct. 16 point. Sachin, yes. Ghosh, yes. Okay, let's move on. Very quickly solve this. Same question, same concept, little different approach, okay? Carnot cycle we have efficiency 0.75. High source, I don't think you will get any easier question than this. 2 marks question. You see, 2 marks question, just one formula. You don't have to write anything. One formula, directly solve this question. Temperature of lower temperature reservoir. What is the answer? What is the answer? What is the answer? Maheshwaran, Sachin, write the question number so that I don't get confused what question you are answering. Question number 11, B is the right answer. Very nice. Very nice speed and very nice accuracy, I won't say, because in multiple select question, accuracy is not that important. Because if answer is little bit approaching your, value, then you can know what is the answer. But accuracy is very important in numerical type question, when you have to write the question. Okay, it's very important. Sachin, tell me, are you able to solve this? I don't think there should be any confusion in this. You should have solved this by now, okay? If one person has answered, that means it is solvable in this amount of time, okay? Maheshwaran, have you solved this? Minus 23, absolutely right. Minus 23. I won't solve this. We will move on to the next question. If you are asking me to solve this, that means that you need to go and revise the concepts, okay? I really think so. Okay, nice. Maheshwaran, have you solved this? Let's move on. Okay. We have a heat transformer that they are first of all giving some theory that is not basically for our use for GATE exam, okay? I mean, at that particular time, it's not important, but anyway. We have a heat transformer is a device that if we supply heat at a certain temperature, it can transfer heat to a high temperature and reject some heat to the lower temperature. That is heat transfer. Now they are saying that I am giving heat to the transformer at 350 Kelvin. How much heat? So if I have a device and I am giving heat, so I have a reservoir at 350 Kelvin. I have a reservoir at 350 Kelvin. Okay? And I am giving 100 kilojoule of heat. Now out of this 100 kilojoule, some maximum heat is transferred. Maximum heat is transferred at 400 Kelvin and the rest is rejected. So let's say it is Q1 and the rejected is Q2. Rest is rejected at 300 Kelvin. That is what the question is saying. Now I need to find out the heat is rejected. So I need to find out this heat. This is my question. Okay? And they are saying the maximum amount of heat that is transferred. That means it is a maximum performance giving cycle or the transformer. That means it is a Carnot Carnot. It is a reversible cycle. It is a reversible device. Okay, so we can use our temperature formulas. Okay, okay, Sachin, just one second. Question number 12. Absolutely right. Yes, very nice. Very, very, very nice. Okay, this is the correct approach. This is the correct timing. The amount of time you are taking is absolutely correct. Okay, it is suitable for the GATE exam. Yes, it is because they are saying the maximum amount of heat that you can transfer. Okay, that means you can apply either Q1 by Q2 is equals to T1 by T2. Either you can apply this, T1 you know, T2 you know, and you can have an energy balance equation. So Q1 plus Q2 is equals to 100. So two equations, two unknowns. Or you can apply Carnot inequality, Clausius inequality, I'm sorry. Cyclic integral of dq by t is equals to 0 for reversible cycle. Okay, so you can write 100 by 350 minus Q1 by 400 minus Q2 by 300 is equals to 0. So equation number 2 will remain same in both the approaches. So either you can use equation number 1 and 2 or you can use equation 2 or 3. I mean, I have shown you to solve this question by two approaches. Either you can use these two equations or you can use these two equations. Okay? Any two equations you can use and solve this question. Ghosh, are you able to solve this? Okay, this is what? This is 4 by 3, right? 400 by 300. So 4 by 3. So you have two equations, two unknowns. Nothing is very complicated here. Okay? Can we move on to the next question? Still 9 questions are left. Maheshwaram and Ghosh, are you able to solve this? Okay, two questions, two unknown, and you will be able to solve this. Okay, you will be able to solve this, I know. Okay, and the answer is 57.14. Okay, so try this if you have not tried this. Okay, now this is, I think, 1 second question. You read the question, you tell me the answer. You read the question, you tell me the answer, and we will move ahead. Not the only amount of time that you require to read the question is the amount of time you require to answer the question. That's all. If you are taking extra time, you are wasting time. Okay? Question number 13. A, B, C, D. Right answer. GATE 2015 1 mark question. 1 mark I mean, question number 13, A, B, C, D. Right answer. Question number 13, A, B, C, D, right answer. So, for an ideal gas with a constant values of specific heat, for calculation of specific enthalpy, we need only temperature. We need, for ideal gas specifically, we need only temperature. Okay, and we all know the concept behind it, right? We all know this. H is equals to U plus PV. It is a function of temperature. This is MRT, so it is also a function of temperature. That means enthalpy is a function of temperature. So let's move on. Sachin, that is correct. A is correct. Please write question number, okay? Now this question, 2 marks, GATE 2015. So we have a Carnot engine that works between temperature limits of A and B. Okay? So we have this Carnot heat engine CE1 and it is working at 900 Kelvin and between 500 Kelvin. Giving you some work as well because it is a engine. Then we have a second Carnot engine that works between temperature B and C. So B is already given and C is 300 Kelvin. All the heat rejected by CE1 to the reservoir B is used by CE2. So let's say if this is Q1 and I reject Q2, that means Q2 is only I am giving. That's what the statement is saying. And then I am producing some work W2 and then Q3 is rejected. Q3 is rejected. For one cycle of operation, if the net Q absorbed by CE1 is, so they are giving 150 megajoule, then the heat rejected to the reservoir C by CE2 in megajoule, I need to calculate. So this I need to calculate. So I have read the question for you, I have drawn the diagram. I think you have got enough time to solve this question. Very quickly tell me what is the answer for question number 14. You got enough time, right? What is the right answer? Carnot engine is there. Efficiency 1 minus T2 by T1 is equals to W1 by Q1. I know everything. I know T2. Right? 500. T1 is 900. I know Q1 150. So I can calculate W1 from here. 49.99. Yes, that is correct. Absolutely correct. Okay. W1 I can calculate. Okay. W1 I got. Then I can write Q1 is equals to Q2 plus W1. So I can calculate Q2. Right? Then for efficiency 2, I can write 1 minus T3 by T2 is equals to W2 upon Q2. Now I know Q2 from here. I can calculate W2. Right? And then I can say Q2 is equals to W2 plus Q3. So I can calculate Q3, which Sachin has calculated. It is 59.99 megajoule, right? Okay. So we'll move on to the next question. 1 kg of an air undergoes a irreversible process between equilibrium state 1 and 2. So temperature is given for equilibrium state 1 and volume is given. Change in entropy I need to calculate. Change in entropy I need to calculate. Air है 1 kg air. R is given. Irreversible process is happening. Okay, irreversible process is happening. So what can you do? ds S2 minus S1. They are saying joule per kg Kelvin. So I can write small S2 minus S1, okay? Now, what is this? CVLN T2 by T1. CVLN T2 by T1. Tell me the answer. What is the answer? Plus RLN V2 by V1. V2 by V1. So, what do we have? Temperature is what? State 1 or state 2. What is T2 and what is T1? T1 and T2 are same. Constant temperature is there. T1 and T2 is same. Constant temperature is there. That means this both. It is 20 degrees Celsius. It is 20 degrees Celsius. Now what is left? R you have given. V2 you have given. V1 they have given. Nothing left. What is left? Nothing. Minus 106. Ajinkya, that is right. Absolutely right. Minus 116.368. That is how I need the answer in a numerical question. Okay. At least 2 digit. And that is absolutely correct. 37 is also correct. Yes. Okay. So I can write it minus 116.36 joule or 37 joule per kg Kelvin. Okay. Let's move on. Now, one side of a wall is maintained at, so what do we have? We have a wall. Okay. One side is maintained at 400 Kelvin and other side is maintained at 300 Kelvin. The rate of heat transfer, that is Q dot. Okay, rate of heat transfer through the wall is 1000 watt. And the surrounding ambient temperature is 25 degrees Celsius. Ambient temperature is 25 degrees Celsius. Okay. Assuming no heat generation, there is no generation of heat inside the wall. So Q dot generation is 0. No heat generation. Q dot generation is 0. The irreversibility due to heat transfer through the wall is. What is the irreversibility? Solve for irreversibility. Irreversibility we all know how to calculate. Irreversibility is equals to temperature of surrounding. T naught. Always T naught. Okay. Irreversibility is always measured with respect to the surrounding temperature. 248 watt. Absolutely correct. Very nice. Sachin. Very nice. Okay. Is it exactly 248 or there is some point something? T naught entropy of universe, or I can say T naught entropy generation, however you want to call it. Okay, entropy generation we all know how to calculate. Yeah, 248.33. Absolutely right. What? Okay. Okay. Entropy generation or entropy, we all know how to calculate entropy generation. People get confused in this. Entropy of universe is equals to entropy generation is equals to entropy in a process. They all are same, and I can write of system plus surrounding. But in process, a lot of people will come also. 247 and 249 will come also. What 249? Okay. So sometimes in process, in question, sometimes they ask for process, but sometimes they refer to only system. So in a process, either your system, you have a system, either it is giving heat, it is giving heat or absorbing heat. Because of this heat given or absorbed, the entropy of the system is changing. But if I am absorbing heat, from where I am absorbing, from surrounding, or if I am giving heat, I am giving to surrounding. So if the entropy of system is changing because of this heat transfer, then the entropy of surrounding is also changing. So in a process, basically we have to combine the entropy change of a system and a surrounding. Okay, but sometimes even in question the language is very confusing. They try to ask only for system, but they say what is the entropy change during this process. Okay, so I don't know what to say for that, but usually for a process, because in process system and surrounding both are involved. Okay, so and for a process entropy will always increase, greater than equal to 0, right? Entropy of a universe is always greater than equal to 0. Entropy generation is always greater than equal to 0, and entropy change of a process is always greater than equal to 0. Okay, so system and surrounding. So now I have to assume a system. Let's say this is my system I am assuming. Okay, or I can assume wall as my system. I can assume anything. Okay, so what can I say? I can say entropy generation is equals to minus Q upon 400 plus Q upon 300. You calculate this. Q is 1000, T naught is 25 degrees Celsius. You can calculate this. 248.33 right answer. Watts. Okay, let's move on. 17th question. Water has a critical specific volume of some value they have given. Now they are saying we have a rigid container, we have a rigid steel tank, closed and rigid, whose volume is this. And we have a mass of water and steam of at this pressure. Mass is given, total mass is given 10 kg. Now that we are heating the tank, now tell me the rise, liquid level will rise or it will fall down. What will happen or remain constant? Okay. So if I draw a TS diagram, I can draw this, and this is the pressure, 0.1 megapascal they have given, and they are saying it is a mixture of water and steam. They are giving critical volume. So critical volume will be here. I should have drawn the PV diagram actually. I should have drawn the PV diagram so that it's easier to show on that, है ना? PV. So this is what is happening. This is what is happening. Okay. Now what is happening? So it is happening at critical volume. Critical volume they will show at some critical point, right? And so critical volume is how much? Critical volume is 0.0003155 meter cube per kg. Okay, this is critical volume. Now what is the actual volume in the tank? We have a tank, volume is given 0.025 and mass is given. So actual specific volume is 0.025 upon 10. So this is 0.0025 meter cube per kg. Meter cube per kg. Okay, so it's easier to show in this. Now what is happening? So because we are more familiar with TH diagram, that's why I am drawing this. Okay, so if this is critical volume, this is critical volume, and our actual volume is slightly less than this. So let's say here we are, that is my actual value of specific volume. Now at this condition, this is the amount of, what is this? This is the amount of liquid or vapor? will rise, that is correct. This is the amount of mass of liquid or vapor? It is the amount of liquid. And this is the amount of vapor. Now what is happening? I am heating it. But you have to mind one thing. This process is not happening at constant pressure. Okay? Constant pressure processes are always open to atmosphere. You see, when in pure substances we say that we are heating it, it is converting from liquid to vapor. That always happens at constant pressure. Constant pressure means what? It is open to either it is open to atmosphere or we are keeping the pressure constant. But they always happens at constant pressure. But here what is happening? It is a closed vessel. It is a closed and rigid vessel. So its volume will not increase because it's a rigid volume. Its boundary will not change. So volume will remain constant. So when volume will remain constant, pressure will increase. So you will go to a higher pressure. You will go to a higher pressure at constant volume. So that is your, now this is your volume. Should I draw a bigger diagram? But are you able to understand this? So now we have reached here. This is my x2. Now you see, this is the amount of liquid and this is the amount of vapor. So this is my amount of vapor. So amount of liquid is increased in the fraction. If the fraction is 100, amount of liquid is increased, amount of vapor has decreased. That means the level of liquid is going to rise when you do this. Okay? So will rise. Is it clear? Yes, Sachin, will rise. I know I have made a very complicated diagram, but I hope you are able to understand this. The concept you are able to understand this. Like it's very congested, that diagram was drawn. Even I don't like seeing it. Okay? But I hope you have understood that. Okay? When you increase this at constant volume, so you see there that the proportion of vapor has reduced and the liquid has increased. Okay? Let's move on. Very quickly tell me, I think you will only read this question and you will be able to tell me the answer. Rigid container volume is 0.5. Actual volume is 0.5. V is 0.5 meter cube and mass is equals to 1 kg of water at 120 degrees Celsius. Now at that particular point, specific volume, saturated specific volume of liquid is given this, and saturated vapor specific volume is given this. State we have to tell. We have to tell the state. A, B, C, D. Is it compressed liquid or subcooled liquid? Same thing. Okay? Saturated liquid. When will saturated happen? Saturated will happen when V actual is equal to Vf. Then it will be saturated liquid. Mixture of saturated liquid or vapor or superheated vapor? Mixture of saturated liquid and saturated vapor. That is correct. C is the right answer. C is the right answer. Okay? Mixture of saturated liquid and saturated vapor. Okay? Because you can calculate actual specific volume per unit mass. So that will also be 0.1 meter cube per kg. And we see that our actual volume is coming between Vf and Vg. That's why it's a mixture of liquid and vapor. Okay? Let's move ahead. Very quickly tell me how to calculate characteristic gas constant. R bar is given. Okay? A universal gas constant is given and R I need to calculate. Gas constant R bar by M. And we have a mixture of ideal gases. So when you have a mixture of ideal gases, then you have to calculate equivalent, molecular mass equivalent, molecular weight equivalent. How will you calculate this? 1 upon M equivalent is equals to fraction of nitrogen upon molecular weight of nitrogen plus fraction of O2 upon molecular weight of O2 plus fraction of CO2 upon M of CO2. So you can calculate M equivalent from here. We know X and 2 is what? 0.6 upon 28 plus 0.3 upon 32 plus 0.1 upon 44, 1 upon M equivalent. We can calculate M equivalent from here. 2 joule per kg Kelvin, let me check. 274.85. Yeah. Okay. M equivalent you can calculate here, you can put it here. So you will get 274.85 joule per kg Kelvin. Very nice. Very nice. Okay. Let's move on to the next question. Van der Waals equation of state for some gas is given. P is the pressure, V is the specific volume, T is absolute temperature, R is characteristic gas constant. I need to calculate the unit, SI unit for A. SI unit for A. Okay. So what we are going to do here? We are going to apply, what we are going to do? We are going to apply dimensional homogeneity. Okay. We are going to apply dimensional homogeneity or principle of dimensional homogeneity. What is principle of dimensional homogeneity? It says that if you are adding or subtracting any two terms, they must be of the same unit. They must be of the same unit. You cannot add or subtract any quantities that if they have different units. Okay. So what does it mean? It means pressure and A upon specific volume square. They must have same units. They must have same units. So if I talk in terms of units, can I say I can Newton per meter square, that is Pascal. This unit will be equal to the unit of A and specific volume. Okay. In fact, let me write it like this. Unit of A will be equal to unit of P, which is Newton per meter square, into specific volume, which is what? Meter cube per kg and square. Isn't it? Now Newton I can write. Newton I can write how? Force into acceleration. Force is Newton is mass into acceleration. So kg acceleration is meter per second square and meter square into meter 6 upon kg square. Okay. So now you know how to do this. There is nothing. Just cancel the units. Kg and kg will get cancelled. Meter 4. So you will get m5 upon kg second square. Is it clear? Principle of dimensional homogeneity. You cannot add or subtract any two terms if they have different units. Okay? Everyone, is this clear? Okay, so this C is the right answer. Let's move on to the last question for today. Okay? Very easy question. Very, very, very easy question. Okay? Tell me what is the right answer. Question number 21. Read this question. There are people watching. I am expecting you to answer this. Which option is correct? Which option is correct? Which combination of the following statement is correct? We need to find out. The first thing they are saying, a gas cools on expansion only when its Joule-Thomson coefficient is positive. We have seen this, right? If you are following me in HPCL, in every session I have done one question on Joule-Thomson coefficient. Okay? So we all know that temperature and pressure we keep constant and we draw isoenthalpic curves. These are isoenthalpic curve. If we join the maximum point, this is inversion curve. This side we have negative Joule-Thomson coefficient. This side we have positive Joule-Thomson coefficient. Okay. So negative side is called as heating side, positive side is called as cooling side. Only when you are on the positive side, only when you are on the cooling side, if you throttle a gas, you will get a decrease in temperature. So it will cool down. Okay? It will cool down. So you must be on this side for the gas to get throttled and cool down. Okay? So that is correct. That means P is correct. Q. For a system undergoing a process, its entropy remains constant only when the process is reversible. Only when the process is reversible. Now reversible could be anything. Reversible could be heat addition, reversible heat addition, reversible heat rejection, okay, reversible adiabatic. So only in reversible adiabatic the entropy remains constant. You see, ds is equals to dq by t. Even if it is reversible, if you are adding reversible heat addition, so entropy is going to increase. If you are rejecting heat, entropy is going to decrease. Only when it is reversible adiabatic, entropy will be 0. So it must be reversible adiabatic, but they are saying only reversible. That means this is wrong. Q is wrong. Okay? A is correct. A is correct. Sachin, please write the question number because now I don't know. But yeah, I mean, A is correct, okay? But writing the question number gives me more confidence that you are answering for this question anyway. So Q is wrong. Now I can only eliminate the options, okay? Here we have Q, so it cannot be correct. Here we have Q, it cannot be correct. Here we have Q, it cannot be correct. The only option is A. Okay? But anyway, let's read option number R. Okay, third option. The work done by a closed system in an adiabatic process is a point function. We all know this. In a closed system, we have dq is equals to du plus dw. Adiabatic process, this goes to 0 and du is equals to plus or minus dw, whatever it is. Okay. And work done is equals to change in internal energy. Internal energy is a property, it is a point function. So in an adiabatic process, work done is a point function. That is correct. Okay. And a liquid expands upon freezing when the slope of on the fusion curve is negative. So when the slope is negative, okay, for water the slope is negative for the fusion curve, okay. So if the slope is something like this for this curve, okay, we do not have this, okay, just one second. So if we have this is the positive slope for fusion and this is the negative slope for fusion curve. If we have negative slope, that means it will expand upon freezing. It will expand upon. So when the water freezes into ice, its volume increases. That does not happen with other liquids. Okay, usually it contracts because solid has higher density, right? 21A, yes, that is right. Okay, so I think that is all for today. Again, I would tell you this is really good if you want to practice questions for GATE. Okay, we will not have previous year questions. These are all new questions that we will bring. And you see, for a particular branch, more than 500 questions from all the subjects. So I will also take thermodynamics and its applications. Okay. And so if you are at a good level that you have covered your theoretical concepts from most of the subjects, it is a very nice series for practice. It will help you practice like anything. Okay. So I would urge to you, I would request you that please attend these sessions. Please attend this series. Okay. If you want to practice the questions, if you want to make your concepts, then it is difficult. Then you have to, you have to go to regular sessions. Okay. So starting from 25th, right? And the name is Champion Series. Please follow BYJU'S Exam Prep YouTube channel. That is the only source of information for you. You can check the sessions there. You can see the schedule there. Okay. So, yes, tell me, Sachin. Sachin, tell me, then we will wrap it up. Okay. This is my Telegram channel. Please follow. I am trying to make it more interactive with some activities or some, but it will take some time. Anyway, So join the channel so that we will be more frequently connected. The only answer you know, I know, is practice. Everyone knows this. And it's not easy. I know this. The only answer is practice. Speed and as well as accuracy. Even don't keep solving the same questions. Okay. Like for example, you are stuck on previous year gate questions. Don't solve again and again the same questions because you will not learn anything new. Sachin, can I ask you to connect on Telegram and ask me there? Because we have a certain schedule that we need to follow, okay? Please join Telegram channel, ask me specifically, okay? And I'll answer it. Yeah, okay, thank you. Thank you very much. You connect with me there, I'll answer, okay? Because we have a certain schedule to follow. I'm really sorry. Okay, anyway, thank you for your time. Thank you very much. We'll meet soon, okay? Bye-bye.